I am Chris Bilby of Bilby3D, and I'd like to welcome Andrea Ye, Sales Manager from Shining3D, and also Xixin Dao, Engineer from Shining3D. Few people online, some people here in the building. This morning's session, we're going to start with 3D scanning and reverse engineering introduction, then go on to unscan applications in various industries, and then finish up with basic concepts of 3D scanning at around 11 o'clock before we take a break. So I'll hand it over.
Okay, so I think we can start from the 3D scanning and reverse engineering introduction first. And again, I want to thank you all for coming to Shining3D Discovery Day, and hope through today's event you can have a better idea of 3D scanning and reverse engineering. So Chris is now showing the scan samples that we are going to scan today. We have some engineering parts, metal parts, and also plastic parts with really high detail. So we'll show you how a Shining3D scanner works with these parts. And FreeScan Combo, our latest 3D scanner with laser light and infrared light.
Maybe later on, a challenge piece, the old pipe bender.
May I know what kind of stuff you are interested to scan? You may share with us, and yeah, we can show you the related scanning and application.
So they Mo, this is Mo. They do performance exhaust.
Yeah.
Is that right?
Yeah, so I work for a company called X-Force Performance. I'm a product designer there. We essentially design and manufacture performance exhaust systems for performance cars.
Wow.
Yeah, so we have our factory in China. We design and prototype here in Australia, and we send off to China for final manufacturing. So, yeah.
Great.
That's
so are
the
you
basis of it.
Yeah. Are you using any 3D scanner?
I am, yeah. I'm using the IronScan HX. So it's new to us, but I've used it a handful of times now. So what we use the scanner for is to, when we bring in a car for research and development, we remove the factory exhaust system. We scan both the under tray, the under chassis of the vehicle and the exhaust system. We use the parameters such as the exhaust hangers and the exhaust outlets, the connection pipes, where the heat shielding is to, understand the restrictions of where we can create our product essentially. Yeah, that's what we use the scanner for.
Yeah, thanks a lot for sharing. Actually, we have many customers also using Shining3D scanners to do some car parts customization. And actually, during my presentation, I will also show a Canadian customer who use iScan to scan the exhaust of the car, and then they make a customized one. Yeah, that makes cooler sound.
Yeah, it's good.
Okay. Listen back to work. So it seems there are some steps of the basic process of the reverse engineering. 3 steps in the green area is what we call the forward design. So that is a very common and universal way for industrial manufacturing. So you got an idea in mind and you draw the CAD file and the manufacturer bring it and got the real object. But what if sometimes you need to copy some design and you don't like to, because you like to copy the design, and sometimes you just, the object is hard to do the measurement and it's not able to get the all the dimensions and for get enough dimensions for the CAD file. So we take that's why we need to do reverse engineering, and here in the blue area on the process the SolidEdge and the GeoMagic essentials can cover. That's a real object you got from somewhere else, and then you can use a 3D scanner to scan it and got the 3D data, and then you will have the mesh file that what we call the 3D data, and then you can do generate an initial model, like do the match all the features. This can be done in the GeoMagic essentials or in SolidEdge. They have some automatic features, functions, and can match all the engineering features and generate an initial model. But apparently this model is not correct, and sometimes this model doesn't have any engineering intent. So you need to do some additional work. You need to restrict with the engineering intent. So like the real object is like square, and we know it's a square, but the 3D data doesn't show it's a square, and the initial model apparently is not a square. So we need to add some engineering intent and to optimize it to the square, and that's why we got the reverse engineering model. And then we can use this model for manufacturing and got the kind of like the real object. So so the important parts, the bridge between the green area and the blue area is the scanning, and that's what we are doing right now. We deliver the scanners and help customers to connect these two parts. Okay. So you might ask why we need to use the scanners for reverse engineering. So the 3D scanners can, if you're using the mesh model 3D data as a reference, so this can improve your working efficiency and the accuracy. So you don't have to manually measure all the dimensions. Yeah. So, especially for some difficult, complicated parts, manually do the measurement will take a lot of time and maybe like 1 to 2 days, and you're using calipers to do the measuring. Sometimes it's just not that accurate. Yeah.
Yeah, so that's the traditional way we do the measurement, and sometimes we just use a caliper, and we draw the draft based on the measurement and make test piece and manufacture it and see if it fits the real objects, and then we need to do some modifications and modify the drawing again and manufacture the text piece again, and just again and again. Say finally you'll find the work piece is fit to the to some other can be assembled to other work piece, and then you got the the final work piece, and then you can use it for production or something like that. Yeah. So with reverse engineering, you just need to scan a path and design, and based on that 3D scan data, and then make the test piece. So you don't have to make the test again and again. So because the 3D data has very high accuracy, and the test piece will fit. Okay. And here comes some examples of the reverse engineering. So some of our customers are doing the car body modification. They scan the original size, like the car body shape, and then reverse engineering to design the wide body kit. Yeah, here it is. Okay. And then here are 4 major steps for reverse engineering. So the first is the very important step is you need to prepare the raw data. That is the mesh data. And then you need to generate some references. You can do it in SolidEdge or GeoMagic Essentials. And then you do the design work based on that references, and then you make the output. Okay. And yeah, so how to do it with SolidEdge and GeoMagic Essentials. Here, GeoMagic Essentials just works like a bridge between the mesh model and CAD format. You can do point cloud and mesh editing and do the alignment and set the cross section. You can get the cross section lines, and you can fit, best fit some geometry features and extra set features, and then also you can do the auto surfacing function to get the nervous surfacing. So I would say GeoMagic Essentials is kind of a very powerful software. Not only, we export the mesh file format. Sometimes it's not just compatible with other CAD software like SolidWorks should be compatible. Like the Fusion 360 or other like SolidEdge. You can import mesh file to that CAD software, but that those CAD software are especially for do the CAD design, so may not be able to process the 3D mesh file pretty well. So the GeoMagic Essentials can convert the 3D model mesh file format to the CAD format like IGS or STEP files. So also GeoMagic Essentials can provide a very powerful mesh repair function. It's better than the ion scan software. So you got a lot of function features in the software to repair a hose or repair a hole or and they have some mesh doctor function or manifolder feature function. Just can help you a lot to clean up the mesh and got a perfect data. Okay, and then so we are going to the first step, prepare the raw data. You can do it in SolidEdge, that's the SolidEdge interface. Also, you can do fix the mesh and align data, mesh cleanup in the SolidEdge. But I would say the SolidEdge software just cannot process the mesh pretty well. So so if the mesh file format, the mesh file size is below than 13 megabytes, then SolidEdge might process it pretty well. 30 to 100 megabytes, and SolidEdge may you may facing some lagging issues, and it's kind of annoying. And if the file size is larger than 100 megabytes, I would suggest just input do the mesh repair work in the GeoMagic Essentials. So in GeoMagic Essentials, also provide plenty functions for the mesh repair and fixing functions here. You got a plenty. And then next step is to generate some references. So in the GeoMagic, in SolidEdge, you can go to the reverse engineering section and using the best fit function to fit all the features, see here. So the plane or cylinders or any other geometry features will be automatically detected by the software, and then you can just click extract the features, and then you got all the features like this. Yeah, and then you can use those features to create a boundary, and then go with the intersect function, and then you got a solid model. Well, but in GeoMagic Essentials, we also provide functions to create features. So these functions can be used for some simple measurement and align to the world coordinates. This is also a very important part because sometimes, especially for the handheld scanners, you may find the output, the 3D data is not aligned to the world coordinates. I mean, you may find the 3D data is at this side and the world coordinates origin is just on the other side. So you need to align them together. So those features can help you to align the 3D model to the origin or the world coordinates. And also in the GeoMagic Essentials, you can also draw some curves on the scan data and then export as the free curves, so which can be used for the designing, like a complicated surface, like the fan blade. That shape is not just cannot be fit by any SP, like spline surfaces or some other models. So you need to manually draw the free curves and divide it into several portions, and then use those curves to create that surfaces would be the best fit. You need to manually draw all the free curves, and then might fit pretty well than the automatic detection function. So okay, and then is design and based on those references. So like I said before, you can extend all the surfaces and use the intersect function and combine all the surfaces to a solid model, just like shown in this video. Or you can generate features with Sketch directly. Well, sometimes you may find the workpiece is kind of easy, so you can just draw the sketch based on that model directly. I will show you later. And then, well, and another way is to directly do mesh editing. So for the SolidEdge, it provide a function is called convergent modeling. So you are able to editing the mesh directly. So yeah, you got the 3D data, you can make a drill on the data or something like that. Okay. Yeah, this is extend all the plane or features, and then make sure they have the intersection, and then you will have a bounded. Yeah, you have all the boundaries, and then you can just use the intersect function here to create a 3D solid model. So the next step is the output. So the output can be used for 3D printing apparently, and also if you're going to reverse engineering some engineering workpiece, you can do machining, or sometimes you can just use the data to do more customize the design works. Yeah, so I think that's a pretty a very brief introduction about the reverse engineering topic. So if you guys have any questions, yeah. So I think you might be very familiar with the reverse engineering, right?
Reverse engineering. Think main. Not. I don't do reverse engineering much yet.
Oh, okay.
But I think it's because we're creating a lot of new products based off references of existing.
I see.
So I use a mesh file as a reference more than anything. But
So you just use the mesh file and design the exhaust and make sure the exhaust is fit to the original.
Design around the constraints of the mesh file. I mean, ideally, I would eventually like to reverse engineer an existing like system, exhaust system. That way, it can be modified to have the characteristics that I want. To then make a new model based off that. But yeah, I think my knowledge within, I know GeoMagic is really good because of it kind of bridges that gap between the scan program and I use SolidWorks.
Yes.
So importing directly from HX to SolidWorks, it's the mesh files just completely out of alignment.
Yeah.
So I use GeoMagic to basically align my mesh file, make sure that it's straight in proportion because that's so important.
Yeah.
And there's a lot of characteristics in the exhaust system which can allow me to do that. So like aligning to world, creating axes and selecting certain parts to insert models like cylinders and line axes as well. So that's, I've kind of just touched the surface on that front, but I know there's a lot more in it. Yeah.
Okay. Great. So
any other
questions?